We're rolling? We're ready? Okay, I guess we're ready. Are we good? We're good. Okay, we're good. What's going on, everybody? In today's video, what are we doing and what are we talking about? So, as you guys can see, new digs, right? The new setup is coming along. There's still a lot of things that I'm working on to fix up. As you guys can tell, the echo in this room is a little bit intense. But I am working on polishing that up, so over time things will improve, but you'll just have to bear with me. So I've got the new setup here, paying respects to the N64 development kits, the partner N64 kits. As you guys can see, I've got the PC system here, and I've got the network system here for the SGI machines. I also have a development 64DD drive over here. Now what's really cool about this unit is it's a development prototype. And so the way that you identify that is on the faceplate around the disk drive, the blue bezel. On the standard development drives, there was an N64 logo imprinted on the faceplate there. And with these prototype models, that little N64 logo is missing. A pretty cool thing that I have in my collection. And I thought that I would just put it on display here for you guys to check out today. Pretty neat. But today's video, we are focusing on the Doctor V64. This is a little backup unit that came out of a company called Bung Enterprises out of Hong Kong. This unit has actually been covered quite a bit online already. There have been a lot of channels that have gone over the history of the unit, demos on operating the menus and how to actually load backup ROMs from a CD, and there's lots of videos on there that are demonstrating that and giving demos on the overall functionality. But that's not what today's video is going to be about. I'm going to be focusing primarily on the computer interface. This is a parallel port for a Windows PC, so that's called it's an LPT parallel port. Now, there have been a couple of channels online that did demo some software running with these units. Can you see that bug? I see the bug. And yeah, so there were a couple of channels that did demonstrate this, but I really want to go into the specifics behind this and demonstrate the settings that are needed on your Windows PC in order to communicate properly, as well as look at a couple of the software programs that you can use to load backup ROM images and stream them directly from your Windows PC over the parallel port. So that's what I want to focus on today and demonstrate that and show you guys how you can do that. So without further ado, let's get the video started. Here we go. Before we get started, one cool thing that I will mention, and that is how the Doctor V64 system was used by the company Acclaim Entertainment during the development of N64 games such as Turok 3. Acclaim used a proprietary development cartridge known as the ArtSend. The cartridge had a high-speed SCSI interface located at the back using a DB25 male connector. This was used for debugging purposes and connected to external hardware. Further details on the ArtSend cartridge are beyond the scope of this video, but I can look at covering this in a future video if there's any interest. Let's move on and look at the internals of the Doctor V64. The Doctor V64 unit internally is comprised of a standard PC CD-ROM drive, as well as two PCBAs. We have power cable assemblies for the CD-ROM drive, as well as the toggle switch. We have the push-button PCBA for handling memory controls, as well as the main motherboard. The heart of the system is a UMC 6561 CF-2 CPU processor. The instruction set to this device is nearly identical to that of the very popular 6502 CPU. The CPU half is believed to be identical to the UMC UA6527P device. We also have a WinBond TV encoder chip, CMOS flash device, and an MPEG-1 decoder chip. The lower half of the board, we have an NEC custom ASIC device that handles the data bus for the parallel port, as well as the cartridge interface. There are also power relays and other passive components as part of the video interface and the power supply. We also have two IDC sockets for connecting the SRAM daughter cards. These are connected externally on the bottom side of the Doctor V64. Bung manufactured cheaper versions of the Doctor V64 motherboard by using epoxy blobs for the UMC 6561 CPU and custom ASIC device. The UMC 6561 CPUs are also known as NOAC, or NES on a chip, as they are often used on NES clone consoles like the Dendy Jr. I spoke with fellow electronics tinkerer Ash Evans on Twitter, aka Electron Ash. He's a very talented electronics engineer, FPGA developer, and also PCB designer. Many years ago, Ash actually spent several painstaking months reverse engineering the Doctor V64's BIOS. He managed to write his own custom BIOS in raw assembly code so that the Doctor V64 could use an IDE hard drive instead of the CD-ROM. This was definitely not a project for the faint of heart, but an amazing contribution for the community. So here we have the basic setup for the Doctor V64 with a monitor, the console, as well as a PC Windows 98 system. To connect the Doctor V64 to the Windows PC, we use a male-to-male end DB25 parallel cable assembly. Next, we have the Doctor V64 power supply connection. Also make sure that you have the adapter for the Doctor V64, which connects to the underside of your N64 console. Next, we have the multi-cable for video and audio. Here we connect the N64's yellow RCA jack to the video input on the Doctor V64. The left and right RCA jacks coming from the N64, we simply connect directly to our monitor. We use an RCA video patch cable to connect the video output from the Doctor V64 directly to our preview monitor. The next thing you'll want to do is to confirm the BIOS settings for your parallel port on your Windows 98 PC. For the parallel port number, select 378 hex. For the mode, you'll want to select PS/2 and not the AT mode. Depending on your motherboard, you may also have options for EPP and ECP modes. You can use either of these modes as long as your Doctor V64 unit is running firmware version 1.70 or above. As you can see here, I'm running version 2.02. Next, make sure we have our donor cartridge inserted into the N64. As you know, this is simply for having access to the CIC lockout chip. Here I'm using Mario Kart 64 to gain access to an NTSC lockout chip. Next, we turn on our Doctor V64 and proceed to boot up the default software that came from Bung Enterprises, that being TPC2 version of the software. This is a very basic DOS-based program that simply transfers ROM files from your Windows PC over to the Doctor V64. It uses two simple commands, out command and the in command. The out command is used to load ROM files directly from the PC over to the Doctor V64. In turn, the in command is used to download files from the Doctor V64 onto the PC. So here we'll use the out command along with the path to our ROM file that we wish to load. And for some reason there was a file not found. Every time it loads a game file, it comes up with this error. So it's possibly just a bug in the source code or in the program. And on our preview monitor there, it'll indicate the number of bytes being transferred. What's also really cool is that the source code is available for this program, which was released by Bung. And so it's pretty cool to be able to play around with this. So I'll also include this in the description for those of you that are interested in checking out the source code to this TPC2 program. So it might be something interesting to play around with and potentially port it over to maybe Python code or something. Once the transfer is complete, we'll indicate on the monitor when you're able to load the game on your N64. We can then boot up the N64 console and it loads up our N64 demo here. I actually used this in a getting started video for N64 programming and have since updated it a little bit. And so as you'll notice here, I've changed around some of the textures as I was playing around with the color blender. It uses some of the N64 joystick controls to change pitch and roll, as well as camera movements. By turning off the console, the unit is then ready to receive another ROM file. When it comes to downloading or dumping memory from the Doctor V64, we have a couple of different options to choose from. One option is backing up the cartridge itself directly to the Windows PC. We can also dump the DRAM of the Doctor V64 as opposed to the cartridge memory. There are also options for dumping the V64 BIOS directly to the PC, as well as dumping the firmware stored on the WinBond flash chip. Today we're going to dump my N64 development flash cartridge, which has a memory capacity of 64 megabits, or approximately 8 megabytes. We press the play button to select the cartridge backup option. The Doctor V64 is now waiting for a response from the development PC to begin the backup of the development flash cartridge. This time we'll be using the in command. You'll also notice that there's a / prior to the path of the ROM file name. Here we've used rom_dump.v64. Our preview screen indicates that a backup has begun, and it also shows the number of megabits that have been transferred. This can take a while depending on the size of the flash cartridge memory. Here we're only transferring 64 megabits, so it shouldn't take too long. If we open up Windows Explorer and navigate to the TPC2 root folder, we will see our new backup file. And if we refresh the screen, we can see that a 64 megabit ROM file has been created. We can now press any key to return to the Doctor V64 menu. Another really cool thing about the Doctor V64 is that it accommodates both NTSC and PAL N64 consoles. So we're going to swap our consoles here and we're going to install my European console. So we'll reconnect our cables and our joystick. And because we're now using a European N64 console, we have to make sure that we have a proper CIC donor cartridge. Here I'm going to use my N64 development flash cartridge, which has a 7102 PAL CIC chip. Before we boot up the Doctor V64, we have to make sure that we have the region switch set to PAL. My trusty assistant here will toggle the region switch over to the PAL mode. We then boot up the Doctor V64 and just make sure that we have a PAL compatible monitor connected. In this case, I'm using a broadcast monitor. This time we're going to run a different piece of software. This is called RTOOL64 and has a nice graphical user interface compared to the DOS software. And here we're going to actually load another demo that I compiled. This was just a test that I had created. The software can be a little bit picky, so you always have to make sure you either have a 64 megabit image size or 128 or even 256. For this demo, I padded the image up to 64 megabits. I also compiled this demo to be used on a PAL European console. We can select the send command to load it over to the Doctor V64. As you can see, it proceeds to load the file directly. And again, our monitor shows the number of megabits that have been loaded. Once the transfer is completed, you'll see a message on the screen. You can now play the game. Also notice that it's a European version and a PAL TV signal. And as you can see, the demo loads up just fine. And now this is a really cool sort of warp kind of effect that I messed around with. This was actually part of the code released by Marshall H in a funnel cube demo that he had released. And I was just goofing around with some of his code and created this little demo and just changed around the text a little bit and allowed the background warp effect to be manipulated, doing pitch and roll essentially again, and as well just camera perspective. So it's a pretty cool little demo, playing around with that effect, and also goofing around with some of the colors and the textures, and that was a lot of fun. So I'll include that in the description for those who are interested in playing around with that as well. Now, what's really cool that I wanted to share with you guys is that I have found a way that allows the RTOOL64 software to run under a 64-bit installation of Windows 7. And that uses a special driver called GiveIO or GiveIO64. So it's pretty awesome. And we just simply run this little batch file that we have, and it will allow us to boot up our RTOOL software on a Windows 7 machine. So we simply navigate to our driver folder, and that's GiveIO64. And there you can see the driver is present, giveio.sys. To run this, we simply right-click on the start.bat file and select Run as Administrator. We click yes, and as you can see here, the kernel driver has been activated and a service has been started. So with this driver service in place, it allows the old Windows software to run on a 64-bit installation of Windows 7. And we start up the RTOOL64 software and select our ROM file of choice that we wish to load. And we'll just select the same Homebrew demo here. And we'll right-click on our ROM, and we can also click on the send icon here at the top. You can also use that. And there it goes. As you can see, the ROM file is transferring over to the Doctor V64. And here the transfer just completed, and we can proceed to boot up the N64, and it will run the demo just as it did before. So there you have it. Doctor V64 interface to a 64-bit installation of Windows 7. Pretty awesome. So that concludes the video today, guys. Hopefully you guys can use this video as a reference now. And for those of you that do have a Doctor V64 unit, you can hook it up to your PC and stream over some backup ROMs and demo that for your friends. It's a pretty cool little unit, and I was really glad to be able to finally do this video demo for you guys. So thanks again for watching, everybody, and I want to give a huge shout out to my supporters. You guys are the only reason that I'm here making content for you, and I really do appreciate the support. And for those of you that are interested in becoming a supporter, you can check out my website. That is behindthecode.ca, and there's a supporters page there that you can check out and think about becoming a supporter here at Behind the Code with Jerry. So thanks again for watching, everybody. Hit the like and subscribe if you can. It is always appreciated. And we'll see you in the next video. Take it easy, and bye for now. Ciao.